Well, then I don't know what to do, frankly. Okay, so we're doing reflections. Everyone remember what reflections are from Friday? So the first thing we're going to do is we're going to have you guys go to the Polygon Transformer. All right. The link is in the event for today. I'm going to put it in the chat. It's also on the assignment that you'll do at the end. But here's the Polygon Transformer link. Let me show you how I want you guys to use it. So here's our Polygon Transformer. We can draw a nice little triangle. Boom. Down here, you've got you reflecting. So you can just reflect right over the y-axis, dot, 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 to get A prime, B prime, C prime. We can show coordinate values to see what happened. My gosh, everything's the same except my x's became negative. You can also reflect over... Oh, who's laughing at me? You can also reflect over the x-axis. You get that right there. Is there anyone in class who could tell me what transformation you would do to turn triangle ABC into triangle A double prime, B double prime, C double prime? Other than reflections. Can you do this in one transformation?
Rotation.
Rotation, exactly. How many degrees?
180 degrees over the origin.
180 degrees about the origin, correct.
Reggie, question.
Yes.
I was looking at the Google Doc assignment that we have to do today.
Uh-huh.
I don't know if it's going to be explained in the book, but the last question was a little confusing about the logos. Yeah.
Okay, so I'll get there in a second, all right, Kanan?
Okay.
Let's wait till I get through my lesson before we ask about that. So, to use the Polygon Transformer, you draw your polygon. You can just do one vertice. You can do a triangle. You can do a full polygon. I like to do triangles, some sort of a polygon like that. Make sure to show your coordinate values to make your life easier. So you can click down here to reflect over the y-axis. Click down here to reflect over the x-axis. You can also reflect over a line such as x equals 5, which would be a vertical line that runs along 5 as an x value. So reflect over x equals 5. Look at that, reflected right over x equals 5. Now, or I could reflect over y equals -2. Boom. All the way down there. You can barely see it. Now, I wanted to show you something that's going to be a little unclear, so I'm going to start over. We'll do 3, 6, 5, 5. Let's check out our triangle. There we go. So first I'm going to reflect over x equals 5. Then I'm going to reflect over y equals -2, or maybe even y equals -1. Oh, that reflected it back. Sorry, let me start over. I promise there's a point here. Okay, so I've reflected triangle ABC over x equals 5 to get C prime, B prime, A prime, and then over y equals -1 to get A double prime, B double prime, C double prime. Now, again, what single transformation could I perform to turn triangle ABC into triangle A double prime, B double prime, C double prime?
Rotation.
Rotation of 180 degrees. But what would be the center of rotation now?
X equals 5.
It would be x equals 5, y equals 1, -1.
It would be
Negative
x
1.
equals 5, y equals -1. What we have created here that you can't quite see are two intersecting lines. One is a vertical line, x equals 5. It's going to run along there. And one is a horizontal line, y equals -1. That's going to run along here. Those two lines meet at one coordinate, which is going to be 5, -1, right there. Anytime you reflect over two intersecting lines, such as x equals 5, y equals -1, you're going to get a rotation of 180 degrees in which the center of rotation will be the point that those lines meet. Before, we did the same thing, but the point the lines met was the origin because we were using the axes. Does that make sense to everyone? How about more accurately? If you are confused, feel free to ask a question now or after the lesson is over. So what I'm going to have you guys do today is I want you to get your math notebooks out, and you're going to go to page 279 of your math book. We're going to fill out tables again like we've done for the other transformations. I would like you to fill them out in your math notebook. Remember, the summative is going to be a test that is open note, so you can use this notebook. So I definitely suggest you do this. I want you to first go to page 279 of your books, copy the 2 tables into your notebooks, and fill them out using the Polygon Transformer. You can either use the digital copy of your book. I can send you the link, but the link is also included in the event from today's class. Once you have finished filling out the tables, there is an assignment that is a Google Doc template called Reflecting on Reflections that is on ManageBack at 11:55 p.m. tonight when it is due. You will answer these 6 reflect and discuss questions regarding the reflections that we've done today. And then Kanan, here, the last question says, even superheroes love using transformations to create their logos. For each of the logos seen here, describe all the transformations that have been used to make it. So let's start, for example, with the Batman logo. Can someone in class unmute and tell me a transformation that would be used to create this Batman logo?
Reflection.
You could do a reflection. Where would your line of reflection be?
Down the center.
Down the center. Could it be anywhere else?
No.
No, it couldn't. It could not be horizontal because the top of the bat is different than the bottom of the bat, correct? So with each of these logos, there are a number of transformations that can be used to create them from an initial pre-image. And I just want you guys to write out which transformations could be used to create them. So that's it. Does that make sense, Kanan?
Yes.
Okay. Does anyone have any questions before you get started? I want you need to use the Polygon Transformer in your math notebook. I included a link to the Polygon Transformer in this chat. There is also a link in the Google Doc assignment and on the event from today. Then there is a Google Doc template that is on ManageBack at 11:55 p.m. tonight, which is when it is due, that I'd like you to complete after you've done the table. That is your work for the day. I am going to be on the Google Hangouts for the next 50 minutes to help anyone out who has any questions or if people just want to hang out. Oliver, loving this pencil to your head thing you got going on here. Are you drawing on your computer screen? No. Are you trying to stab me with the pencil through the camera? All right, that's all I got for you guys. You can take off. I'm going to be here if you have any questions or if you just want to hang out. Good luck.
I don't get your sheet on the Google Doc. I don't understand the first question.
Have you done the
Yeah.
assignment?
Yeah, I did the book thing.
You already did the book thing. So the first question is, what single transformation produces the same results as consecutive reflections over 2 parallel lines? Right? So let's go to our Polygon Transformer. So if we draw this, I'm going to reflect over a line. We'll say x equals -2. Oh, that's translate. Reflect over x equals -2. We get that. Now it wants me to reflect over a parallel line, which is going to be, we'll say x equals -10. So,
What?
Nico, what do you mean? What? Which part was confusing?
Parallel. I don't understand the parallel lines part.
So I started with x equals -2. That's going to be a line that runs vertical at x is -2, right?
Oh, yeah.
And then I reflected over x equals -10, which is going to be a line that runs vertical at the x point of -10. Those 2 lines are parallel, correct?
Yeah.
Right. So now I've reflected consecutively over 2 parallel lines. Now, what single transformation could produce that same result?
Not rotation.
Right.
And not reflection. So the
Oh.
answer must be, I don't know what the name of it's called.
Translation. That's the one where you just move it.
Translation.
Exactly. So anytime you reflect over 2 parallel lines, if you consecutively reflect over them, you could produce the same transformation with translation. Does that make sense?
Yes.
Okay. I'm going to stop recording, guys.